In the first module, you will learn the fundamentals of clinical data collection and archiving systems. We will use some examples of clinical data sets similar to real clinical data. You will also learn the techniques for extracting and analyzing clinical data. These are processes that you can eventually practice by yourself using your clinical data. We may also ask to IT experts in your institution to perform these tasks in collaboration with you. Using these tools, you will be able to discover the relationships that are present among the clinical data and obtain deeper information on the medical activities that generate these data. Being able to analyze your data is a fundamental requirement to improve your daily work, as well as to speed up some of your procedures. In the present lesson, lesson number 2 of this course, you will learn how a clinical database is structured, with some examples on how data are related. Then you will learn in lesson 3 and 4 how we can select data in a database using the relations among the data stored. During lesson 5 and 6, you will learn with some practical examples how to inspect data and how to export them for further analysis. At the end of this course, you will know how it is possible to use clinical database for data retrieval and analysis. That will be the topic of the other courses of this package in data analytics. The systems commonly used in clinical settings to store patient data are now almost entirely digital. You may already be familiar with some of these software applications for your routine work. The user interaction is usually obtained by a graphical interface, with the possibility to insert and visualize clinical data. Information generated during the clinical practice is stored in the so-called electronic medical record, or simply EMR. The digitalization of this information is obtained by different technologies and different software applications. Some data is then captured by the instrumentation and directly transferred to the EMR. Other data is manually entered by some users through the software interface. An example of a typical user interface of a clinical software is shown in this image. From this interface, you cannot understand how clinical data are organized and stored within the computer memory. We will see now how this is accomplished. The clinical data stored in medical records are of different types. Different data types can be grouped in 3 main data types: text, dates, and numbers, as it is listed here. There are therefore data represented by text, consisting in alphanumeric characters. There are data about dates, with day, month, and year. The third type of data is stored as number. Numbers with different formats can be divided mainly in integers or decimals. As shown in this table, length of numbers and decimal places are predefined for each variable, that is a piece of numerical data. Each number, date, or text is stored in a memory location in the computer. The memory space occupied by different variables is organized in a table, as represented by the column and row array that is visualized here. The table is composed by different cells, each identified by the number of the row and the number of the column. Each cell is also called field of the database. Usually, data of a single patient or of a single event are stored in single lines in the table. As you see, the table is very similar to a spreadsheet. Here in this example, you can see some patient data artificially created. As shown here, data of a single patient is contained in a single row that we call patient record. In the patient record, the first cell is used to store an identification entity. In this case, the identification entity is the patient ID. To memorize and organize a large amount of data, we cannot use a single table. If a large set of clinical data must be stored for different patients and different activities, a unique table would have many empty cells. In addition, data could not be easily related, and to make data handling more efficient, data are stored in a number of tables. To connect data contained in different tables, a system is used to put data in relation. In this case, we speak of a relational database. Each table in a relational database contains a uniform set of information, as shown in this example. We have patient data, data from different visits, data from different lab tests. Data of single patients are related among different tables by a field designed as primary key, as shown in this image. With this system, a relational database allows storing information separately in multiple tables. Tables are then linked together in the following way. These three tables contain the names of the fields. The primary keys, one of the fields, allows to connect data of individual patients in different tables. For example, patient ID allows to link data of the patient data table to the visits table. In addition, the primary key visit ID allows connecting data of the visits table to data of the lab test table. A more complex example of relationships among different tables is represented in this image. As we can see, a heterogeneous amount of data belonging to the same patient can be efficiently stored in several tables. These data can be easily related by the use of primary keys that allows the connection among data of the same patient in the different tables. So please remember that the data you see in an electronic patient record is organized in this way inside the computer memory. Keeping in mind this structure will allow us to access individual clinical data in a database. Since we know how clinical data are related among different data tables. This ends our lesson on the structure of a clinical database. Before continuing with the next video, please answer the questions on the platform. Please follow the instructions provided with the questionnaire. Once you have completed your answers, please discover the correct answers, and in case some of your answer was wrong, you can provide new answers. You will be able to follow your performance on the basis of correct and wrong answers, lesson by lesson. After successful answers to the questions, please go to the next lesson.